Good morning, students. In the last class we discussed about acceleration. So what is acceleration? It is defined as the rate of change of velocity. So if the rate of change of velocity is increasing, means the velocity of the body increases by accelerating, then we can say that it is called acceleration. If the velocity decreases, that is called deceleration or retardation. Since acceleration depends upon change of velocity, velocity is a vector quantity, so that acceleration is also a vector quantity. Now, as usual, we are going to discuss the types of acceleration. So, in the similar way, we have types of speed and velocity, we have types of acceleration. The first one is what? Uniform acceleration. So, what is uniform acceleration is? It is defined as, means if the change of velocity is constant, means for example, first hour or first minute you travel with a speed of 10 km per hour, next minute your speed rises to 20, next 30, next 40. So what happens here? You are moving with uniform acceleration. So the change of velocity with respect to time is constant. So it is defined as, or the rate of change of velocity is constant, then it is said to be having uniform acceleration. So the best example for a body having uniform acceleration is, so any body, its acceleration is, for example here, if you take a car traveling with a speed 60 km per hour. So for every half an hour you are changing the speed to 10 km per hour. So what happens here? It is moving with uniform acceleration. Next one is non-uniform acceleration. In this case we can easily say that the rate of change of velocity is not constant. If the rate of change of velocity is not constant, then the body is setting having non-uniform acceleration. Next one is what? Average acceleration. So here the simple formula, if it is average speed, the total displacement by total time taken. If it is average velocity, the total displacement by total time taken. If it is average acceleration, so what it depends? The total change in velocity to total time taken. So we can write A average is equals to V2 minus V1 by T2 minus T1, where V1 is initial velocity, V2 is final velocity, where T1, T2 are the time intervals. Next, last one is instantaneous acceleration. What is instantaneous acceleration? So the total change in velocity, the small change in velocity when time tends to be 0. So any very fraction of seconds, what change of velocity you have done, we can say that that is called acceleration. So the change in velocity of an object when time tends to be 0. So I can clearly explain the difference between average acceleration and instantaneous acceleration. So here also change in velocity, but here also change in velocity. So here, if you take a normal car, to raise the speed from 0 to 100, it takes more time. If you take the same thing as sports car, so in a very fraction of seconds it reaches 100. So the time span is very less. We can reach maximum velocity. So that case we can say that instantaneous acceleration, the best example. Okay. So here EA equals to limit delta t tends to 0, change in velocity by time taken. When time tends to be 0, what is the change in velocity? It can also be written as A is equals to dv by dt. So this is about acceleration. So how many types of acceleration as we have? 4 types: uniform acceleration, non-uniform acceleration, average acceleration and instantaneous acceleration. Here previous case we discussed about displacement time graphs. Now we are going to discuss about velocity time graphs, which is very important. So by seeing velocity time graph we can describe, we can easily explain the motion of object. All the quantities of motion can be obtained in velocity time graph. So first I am taking not graphs, just examples. That take a velocity time graph. So here this body is moving with uniform acceleration. As you know, the slope is constant. Let us see what will comes. Let us take slope of this line which is passing through origin. This is V2 and this is V1. This is T1 and T2. Now what is the slope formula? M is equals to Y2 minus Y1. Here what is Y2? V2 minus V1 by T2 minus T1, that is equals to A average. So the slope of velocity time graph gives average acceleration, whereas the slope of displacement time graph gives what? Average velocity. If x is replaced by v, it gives what? Acceleration. So A average is equals to V2 minus V1 by T2 minus T1, that is equals to tan theta. So this is one what we can get from VT graph. And now 3 marks question important of this chapter. What is that? Is show that area under VT graph gives displacement. So they are asking that the area under the curve of VT graph should represent displacement. Let us see whether it is true or false. Let us take first VT graph. Here we are assuming that the body is moving with uniform velocity. So velocity is constant. Is it right? See, velocity is there. At 0 time the velocity is v. After time t also its velocity is v, means the body is moving with uniform velocity. Now let us take that this as A, and total time taken is, this is B and this is C. Area under the curve, area under the curve of VT graph is equals to what? So this is of the shape of what? A rectangle. So area of rectangle is equals to length into breadth. What is length here? OA. What is breadth? OC. What is the value of OA? Velocity v. In what time? Time t. So v into t. So area under the curve of VT graph is giving what ma? V into t. Let us take what is velocity. Velocity general formula, displacement by time taken. From this, displacement is equals to velocity into time taken. So have you seen here RHS are same, then we can equate LHS. So from 1 and 2, what we can write here? S is equals to area under the curve of VT graph. So if you want to calculate displacement in a velocity time graph, the area under the curve gives displacement, the slope gives acceleration, as well as velocity time will be there in the graph. So we can get displacement, velocity, acceleration and time by seeing the velocity time graph. Let us take some examples of VT graphs. As previous we discussed like position time graphs, here we are discussing same way velocity time graph. So as usual here, what we should consider along y axis time, along y axis velocity. So the first graph is this one. What it represents that at time 0 its velocity is v, after time t seconds also its velocity remains v. So at what time also you are seeing that the time velocity remains constant. So this graph represents that a parallel line, a line parallel to x axis represents body moving with uniform velocity. So uniform velocity, okay. Now there is no change in velocity, right? Acceleration is equal to what? Final velocity is v, initial velocity is v, time taken is t. So acceleration of a body moving with uniform velocity is 0. So any body moves with uniform velocity, its acceleration is what? 0. Next, here if we take anywhere the slope, what are you getting? All the cases slope is constant. So m is constant. Then already we have proved that m is equals to average velocity, acceleration is constant. So if a graph represents a line passing through origin, then the body is moving with uniform acceleration. So this body has uniform acceleration. Next, so here slope is increasing. So slope is increasing, acceleration also increasing. So this represents what? Dot non uniform acceleration, means accelerating body. So here velocity keep on increasing. So this represents the graph of what? Accelerating body. If a graph represents like this, the slope go on decreasing. So m is decreasing, means slope is decreasing, acceleration also decreases. So this is representing that what? Non uniform acceleration. So this body is having deceleration or retardation. So which our graphs are very similar to velocity time graphs. Let us take an example for how the questions will come based on velocity time graphs, based on displacement. Let's see. So a graph is represented like this. They given time intervals also. This is 2 and this is 3. This is 2 and this is 4. This is velocity time graph. The question is calculate the displacement of a body in 3 seconds. So we have to calculate the displacement of body in 3 seconds. Here which graph? Velocity time graph. How to calculate displacement? Area under this curve gives displacement. So S is equals to area under curve of VT graph. So, what is the area it has? It has one rectangle and one trapezium. Okay, let us take that. If you are getting confused, we can write two rectangles and two trapezium. So, here if you give names, first this is area of rectangle. What is the length here? 2. What about the time taken? Breadth 2. Plus again one more rectangle here is there. What is the rectangle length here? 2. Breadth is 1. Plus now this is a triangle. What is the area of triangle? Half into base into height. What is the base? 1. Height 2, it extended from 2 to 4, not 0 to 4. So, you should consider 2. 2 to cancel, 2 2s are 4 plus 2 plus 1. So, the displacement of the body is what? 7 meters. If here the velocity is given in meter per second and time is measured in seconds. So, this concept is very important. Next, we are going to discuss the important derivations of this chapter called kinematic equations. So, in every exam of first PUC, out of these 3 derivations, you will get one derivation for 5 marks. So, if you understand this one, we can easily go through that concept. So, please refer this for the next class. We can discuss kinematic equations of motion in that chapter. Clear?